Math 3, Unit 8, Module 4, Part 1, Test Corrections. I'm going to do one of each type of problem and then leave you to do the other type of practice problem so that you can get ready for the Unit 8 retest if you are hoping to take that. Power Standard 1.1 and 5.3 for these first 4 questions. Number 1, Brian can complete 8 jobs in 10 hours. So 8 jobs in 10 hours. Vicky can complete 9 jobs in 9 hours. So 9 jobs, 9 hours. Working together, how long will it take them to complete 20 jobs? So the way I like to set up these work problems is I like to do the number of jobs per time times whatever the total time it takes the workers to do their total jobs together. So the X that I just added in there, that's the time it takes Brian and Vicky to do something working together. And that's something that they're doing is the total jobs, so the 20 jobs. So that's Power Standard 1.1, just setting it up correctly. For the actual solving part, there are lots of different ways to do it. The way we did it in class is we multiplied all of the terms by the least common denominator so that we could get rid of all of the fractions. So the least common denominator would be 90 because that's the least common multiple of 10 and 9. So I'm going to multiply all of my terms by 90, by the least common denominator. The whole point of doing this is to cancel out the fractions. So in that first term, 90 divided by 10 is 9, so we have an 8 and an x and a 9 left over. In the second term, 90 divided by 9 is 10, so we have a 9 and an x and a 10 left over. And then 20 times 90 is 1800. Then we just solve like normal from here. So 9 times 8 is 72, and then the x comes with you. 9x times 10 is 90, x equals 1800. And then 72 plus 90 gives me 162x, which equals 1800. Divide. And then I think I actually remembered to put rounding directions in for once. So we're rounding to the nearest tenth. So that's the first number after the decimal point. So 1800 divided by 162 is 11.1 repeated. So we're going to go with 11.1. And then let's get our unit of time in there. So they were measuring everything in hours, so we'll go with hours. So number 2 is left for you to do. On number 3, Laura can wash 3 cars in 60 minutes. When Laura and John work together, they can wash 5 cars in 50 minutes. So this setup's a little different just in the fact that we know the time it takes working together. So in the last problem, that was x. In this case, we know that x is going to be 50. So I'm going to do 50 here. Our total jobs that Laura and John can do together is washing the 5 cars together. So that's our total jobs. And then for John, we want to know how long it's going to take him to wash 2 cars. So number of jobs would be 2 cars by himself. So we don't know the time. And then we need to multiply John by 50. So again, the top of the fraction is number of jobs divided by the amount of time, and then times the time it takes them working together to complete their total jobs. So the 50 is them working together, and the 5 is the total jobs. As far as solving this, our least common denominator should be 60x. So we're going to want to multiply everything by 60x in order to get rid of all of the fractions. So on that first fraction, 60 and 60 cancels out, and you're left with 3 times 50 times x. On that second fraction, the x and the x cancel out, so you're left with a 2 times 50 times 60. And then on the other side of the equal sign, 5 times 60x is 300x. And then we should just solve like normal from here. So 150x plus 2 times 50 times 60 is 6,000 equals 300x, and then keep solving. Subtract 150x from both sides. 6,000 equals 150x. Divide by 150. Divide by 150. And we get 40. So we didn't even have to worry about rounding. And then as far as units go, let's take a look here. What units do we have? Minutes. So number 4 is left for you to do. The next section are questions that are just Power Standard 5.3. So on number 5, when we're trying to solve radical equations, we have to isolate the radical on one side of the equal sign first. So in number 5, that's already been done for us. In order to get rid of a square root, we have to square it. Whatever we do to one side of the equation, we have to do to the other side to keep it balanced. So 2x plus 8 equals x squared. Since this equation has x terms and x squared terms, we want to get everything on one side equals to 0 so that we can factor and solve. So I'm going to subtract 2x and subtract 8 from both sides of the equation. So 0 equals x squared minus 2x minus 8. So now it's time to factor. I see no GCF, and I see a basic trinomial. So we're looking for two numbers that multiply to the negative 8 in the back. Those same two numbers need to add up to the negative 2 in the middle. So negative 4 and positive 2. Set each factor equal to 0, solve for x. Now the thing a lot of people forget, we need to check. Because we don't know if these answers actually work, we really need to check them. So I'll do the 4 first. So I take 4, I plug it in for x back in the original equation, and then I just simplify to see if it actually ends up equaling a true statement. So 2 times 4 is 8. 8 plus 8 is 16. Square root of 16 is 4. So yes, x equals 4 does work when I plug it back in. How about the other one? How about negative 2? So 2 times negative 2 plus 8 equals negative 2. Under the square root there, negative 4 plus 8, which is square root 4, which is 2. 2 does not equal negative 2. So that does not work. I have to throw out that second answer because it's an extraneous solution. Number 6 is left for you to try out. On number 7, let's put that 1 in the front over 1 to make it look like a fraction. And then we want to try to find a least common denominator, but that last fraction has a trinomial in the bottom that we should try to factor. So we're looking for two numbers that multiply to negative 30 and then add up to 1, because there's an invisible 1 in front of the x. So how about x plus 6 and x minus 5? Now that we have that taken care of, let's jot down our domain restrictions and then our LCD. For domain restrictions, we just want to jot down the x values that would make any of the denominators 0, because that means x cannot be those values. So from this second term, x cannot be negative 6, because if it was, then that denominator would be 0, and we're not allowed to divide by 0. Looking over here in the last fraction, x cannot be 5, because if it was, the denominator would be 0, and we cannot divide by 0. So x cannot be negative 6 or 5. As far as a least common denominator goes, it's basically just like one of everything we see in the denominators. So I see a 1, I see an x plus 6, and I see an x minus 5. So our LCD is x plus 6 times x minus 5. We want to multiply all of our terms by the least common denominator in order to cancel out the fractions. So it's going to get a little tight here, but I'm going to multiply everything by x plus 6, x minus 5. That way we can cancel out all of these fractions. Now, that first fraction, the 1 times x plus 6, x minus 5, rather than wasting your time trying to FOIL that out, you already know what it is FOILed out. It's right here. So just jot that down. X squared plus x minus 30. That's what that is equal to. Next term over, x plus 6 and x plus 6 cancel out. So you're left with the minus x, and then don't forget to put parentheses, and then the x minus 5 up top. Equals, last fraction, x plus 6 and x plus 6 cancel out. X minus 5 and x minus 5 cancel out. So you're left with 3x plus 3. On the left side, let's distribute to get rid of the parentheses. So negative x times x is negative x squared. Negative x times negative 5 is positive 5x. And then now it's just a matter of combining some like terms and continuing to solve. Ooh, we're in luck. X squared minus x squared is going to cancel right out. So we're done with our x squareds. X plus 5x is 6x. And then that minus 30's all by itself equals 3x plus 3. And then we should be able to just solve like normal from here. So I'll do minus 3x minus 3x. And then plus 30 plus 30. So 3x equals 33. Undo multiplication by doing division. And we get x equals 11. Now at the end, double check and make sure that your answer is not one of the domain restrictions. So it's not, so we're good to go. We don't have to throw out the answer. If it was one of the domain restrictions, we would have to throw out our answer. So 8 is left for you to try out. And then here comes Power Standard 7.1. So on number 9, we have a parent function of f of x equals sine x, and then we list out all the transformations that have happened to create g of x. So that negative sign in the front is a reflection over the x-axis. The 3 in the front, those are always either your vertical compressions or vertical stretches. So since 3 is greater than 1, it's a vertical stretch. If the number had been in between 0 and 1, it would be a vertical compression. So vertical stretch of 3. Inside the parentheses right here, if we're subtracting 90, we actually go right 90. So those horizontal translations are always the opposite of what we think they should be. So since it's negative, we actually do right 90 degrees. And then, that T's bothering me, right. And then in the back, minus 2. So those vertical translations are always as they should be. So up is positive, down is negative. Vertical translation down 2. So you could try out number 10. And then I'll do one more for you. I'll do number 11. So on number 11, the parent function is cosine. And then we want to see how it transformed to get g of x. So that negative sign inside the parentheses would be a reflection over the y-axis. And then the horizontal compressions and stretches are, again, kind of goofy, opposite of what we think they should be. So that 1/4, that's the b value. If b is in between 0 and 1, it's actually a stretch, a horizontal stretch. And it's always by a factor of 1 over b. So it's technically a horizontal stretch of 4. If that 1/4 had been like a 5, then that would be a horizontal compression by 1/5. So it's always the opposite. So if it's greater than 1, it's a horizontal compression. If it's in between 0 and 1, it's a horizontal stretch. And it's by a factor of 1/b. And then that 3 in the back, that's pretty easy. It's your vertical translation up 3. And then you could try out 12. 13, we have a periodic function, and then we get to do all the key features. So the period is how long it takes the graph to complete one full cycle before it starts repeating itself again. If you can start at an x value of 0, that kind of makes your life easier. So on this particular picture, I'm going from peak to peak. My largest x value is 4, and then my smallest x value is 0 for that one cycle of that graph. So for my period, it's 4 minus 0, which would be 4. So that's how many x values it takes to complete one full cycle before the graph starts repeating itself again. As far as max values, just highest y value on the graph, so 1. Min values, same idea, but lowest y value on the graph, so -4. Amplitude is equal to 1/2 times the absolute value of the max minus the min. So in this case, the max is 1, the min is -4, so be careful with that double negative inside the absolute value bars because that turns into a positive. You'll notice we get a decimal for the amplitude. That's fine, that's okay, you can get decimals. You just need to make sure that your amplitude is positive because it's the distance from the midline up to the top, or the distance from the midline down to the bottom. Distance cannot be negative. And speaking of midline, midline is y equals the max plus the min divided by 2. So you're basically averaging your max and your min. So it looks like we're getting y equals -1.5. And I do need to see the y equals. Don't just leave it -1.5. It needs to be the equation of the horizontal line. And then on the graph, so you can visualize this, -1.5 would be right about here. So the distance from that purple line up to the top, that distance should be 2.5. And the same thing going down, it should be a distance of 2.5 to go down. And sure enough, if you count it out, it is. So then the last one, number 14, is for you to try, and then you're good to go.